Okay, so this video is going to be over rationalizing the denominator. And here's the biggest thing that we need to realize, is we need to know the difference between some kind of rational number and some kind of irrational number. Now, a rational number is a number that can be written as a fraction, or a way of thinking of it, it's something that kind of terminates, that kind of is just done. And so, a good example of a rational number is a number like 3. An irrational number is not a rational number, meaning it just kind of goes on and on and on forever. So a good way of looking at an irrational number would be like the square root of 5. This number, when you bring it up on your calculator, you put in 5, and you hit the square root button, and see how this thing goes on and on and on forever. So it even goes further than this. Like if I could keep expanding it, which it won't show me, but if I could keep expanding, there'd be more and more digits out here. So what this means for like mathematicians is mathematicians really don't like to have denominators that are irrational. Say you get something like this, 3 radical 5. Mathematicians really don't like that, and the reason they really don't like this is because you got to think of dividing some number by something that you have no clue what it is. So here's how they go about fixing it. They multiply the top and bottom by radical 5. I want to think about why this would work for a second. Well, the big reason this would work is because if you multiply something by itself and then take the square root, you get the same number back. Like 5 times 5 would give you 25, and then you take that square root and you get 5 again. Take any possible square root that you could think of, like any possible combination. And when you times it by itself, it will always give you the number that was inside the square root. And if you can think of one that won't do that, you gotta let me know, because you're in for a lot of money, because it would break down math. So for this case, choosing 5 is good because we'd get 3 radical 5 over radical 25, and that would give me exactly what I needed, which is 3 radical 5 over 5. And that would be my final answer right there. Let's try another one. So maybe we have something that's like 2 radical 6. And we're trying to figure out what this one. Again, we're going to use the same trick. Because I know this denominator, I want to get rid of it, we're going to times the top and bottom by radical 6. And when we do that, we're going to get 2 radical 6 over radical 36, which we know would be 2 radical 6 over 6. Now, I'm not done at this stage, because when I look at this, I could reduce this fraction that I see over here and here. And when I reduce that fraction is going to give me, well, 2 and 6 can kind of divide each other, and I'll get radical 6 over 3. And that would be my final answer. Another way you could write this is 1 radical 3, because you divide 2 by 2 and 6 by 2 and get 1 radical 3. Either way, that's an acceptable answer. Let's try one more of these. This will be a little bit different. So let's say we have 5 over radical 7. Now when I'm doing this, again, I'm not going to worry about this number on the top, because I don't care that that's a radical. The one that I care is that 7, so we'll times the top and bottom by radical 7. This will give me radical 35 over the square root of 49. And when I do that, now what I'm going to do is I'm going to take this square root. So when I take that square root, I should get radical 35 over 7. And again, that would be my final answer. We could check to see if this simplifies, but the only thing it breaks down to is 5 and 7, and neither of those are nice square roots that we could do. So that would be my final answer. Okay. So I think you're probably getting the hang of these these radicals as we go along. There is one more kind of example that's nice to do with these radicals, is to put some numbers. Now what happens for some people when we have the number in front is they want to times this by 3 radical 2. And you can do that, but I would not. Like, you'll get the correct answer, but it takes a little bit more work. And the reason I wouldn't do that is because you want to really focus on what you're trying to get rid of. What you're trying to get rid of is this radical 2. You really don't care about that 3. It's kind of just going to stay along for the ride. So when I think about this and I do that, we'll see very quickly that when I do 2 times 2, I would get 5 radical 2 over 3 radical 4. And then that square root of 4 would become 2, so I actually do get to cancel it out. And that would give me a final answer of 5 radical 2 over 6. So again, the big key thing there is you can kind of see that we really only care about getting rid of these radicals on the bottom. That brings us up to the slightly more difficult problems, where we have to rationalize a little bit difficult or more difficult radicals. Okay, so in this kind of problem, this plus sign is going to ruin everything. And the reason why it's going to ruin everything is, let's say we were like, oh, I see what I'm going to multiply. I'm going to multiply by radical 7. Well, what happens there is you get 4 radical 7. And then this kind of is distribution. So we would distribute, and when I distribute here and here, I would get 3 radical 7 plus 49. Well, the 49 would simplify, and I would end up with this. Now this should worry you. And the reason that answer should worry you is because of this thing right here. You still have a radical on the bottom. It's not rationalized. And when you look, all we really did was we moved this radical 7 from the back to the front. And if we times it by radical 7, the same process is going to happen. Like, it'll just bounce back and forth. So this is a really bad way of doing it. So when you have 2 things on the bottom, you can't use just a single number because it won't work. So we got to try something different. So let's take the same problem and try something a little bit different. Here's what we're going to try to do. We're going to find its conjugate. Here's what a conjugate is. It's all of the same numbers, but I change up the middle sign. So if you can see, all the numbers are the same, but I've changed up this middle sign so that they're different. Let's see why this works. Well, again, this is going to act like distribution, so the 3, So the 3 is going to go to the 3, and the 3 is going to go to the 7, and the 7 is going to go to the 3, and the 7 is going to go to the radical 7. So what I end up with on the bottom is I would end up with 9 minus 3 radical 7 plus 3 radical 7 minus radical 49. I would do the same thing that works here. I would distribute the 4 to the 3 and the 4 to the 7, which would give me 12 minus 4 radical 7. Now, once I've got it to here, I'm going to kind of look through this. And when I look through this, I go, oh, this is why this works. I have a negative 3 radical 7 or a positive 3 radical 7. Well, what are those things going to do? They have to cancel out. So they cancel out, leaving me with my bottom to be 9 minus radical 49. And you might still go, hey, Mr. Rose, we still have a square root on the bottom. And I would say, yes, we do have a square root, but this is a nice square root. That square root can be simplified. And that square root can be simplified to be 7. So I really have 12 minus 4 radical 7 over 9 minus 7, which would make my final answer 12 minus 4 radical 7 over 2. And we finally rationalized the denominator. I know this takes a little bit, but you can see that the process isn't too bad once you know the conjugate. You just go through and you do the binomial multiplication that we did yesterday. We can try one more of these problems, so we're going to do that. But realize that the process I'm going to speed up the process just a bit this time. So let's say we had a radical 3 on the top, and then on the bottom I had radical 7 minus radical 5. Okay? So let's even make it a little bit trickier. We'll put a 2 on that. So we've got a pretty difficult problem right here, and we're going to figure out what it would be. So again, I want to find its conjugate. So its conjugate is all the same numbers, except the middle sign is going to be the opposite. We're going to go through and we're going to multiply, we're going to distribute those bottoms and distribute the tops. So we're going to, whoops, oh, hold on, pen. So we're going to distribute this here, and this here, and this here, and this here, and this to both. So let's do the top first this time. So I'd get 2 radical 21 plus 5 radical 3. And then on the bottom, I would get 4 radical 49 plus 2 radical 35. And then when we distribute these bottom two, we would get negative 2 radical 35, and then negative radical 25. So now we can try to simplify as much as we can. We know that these two middle things are going to cancel. I'll get 2 times 7 because the square root of 49 is 7, minus 5 because the square root of 25 is 5. And then we'll have 2 radical 21 plus 5 radical 3. So my final answer would be 2 radical 21 plus 5 radical 3 over 14 minus 5, which you could simplify that bottom a little bit more and get your final answer to be 2 radical 21 plus 5 radical 3 over 9. Okay? Again, you want to try these different problems. If you get stuck or need help, please ask questions.